Today we're going to be solving an indefinite integral. It's a trigonometric question. Okay, so our question is evaluate the integral of cos theta over sine squared theta d theta. First thing you're going to do is rewrite it as a product instead of a quotient. So first you have cos theta over sine theta. Well, not instead of a quotient, because you still have a quotient right here, and it becomes a product as well as you have fractions, but this helps you in solving it. So a lot of times when you're doing integrals, you'll see that they separate the bottom. So if you're stuck, maybe try separating your fractions into different parts and you can integrate it that way. So this is, so when you multiply this out, you'll get cos theta over sine squared theta. Oh, this is not squared. Should I erase that? This is not squared. Okay. Now we're going to simplify it. So cos over sine is cotangent, just like sine over cos is tan. So this is the reciprocal. So cotangent of theta. And 1 over sine is cosecant. Cosecant theta d theta. You can put brackets around it if you'd like. Okay. Now, this is a known rule. Just like if you had the integral of 1 over x, you should know that's ln x. Just like if you know the derivative of ln x is 1 over x. So this is the same thing. This will be negative cosecant theta. This negative cosecant theta, when you take the derivative of that, you will get cotangent theta cosecant theta. So the antiderivative of that, the antiderivative of this, is this. These are rules you should memorize. There should be a whole list if you Google it. Okay, so this is just because we know it. I didn't derive it from anywhere. We should know this, that this antiderivative is going to be this. Okay, and now anytime you're finding the indefinite integral, the antiderivative, you need a plus c, constant at the end. Because if you have negative cosecant theta plus 5 or plus 8 or plus any random number, when you take the derivative, you would get cotangent theta cosecant theta. It doesn't matter what the number is. So it could be any number. That's why we put a plus c. Okay, so that is your answer. And yeah.